Good morning, and my name is Jae Wook. I'm working on the messaging hub. In this session, how the messaging hub became an independent and universal platform, and I'd like to explain its process of developing that. And this is agenda of this session. And what is a messaging hub is the first topic, and followed by messaging as a service. This is the platform perspective of messaging explanation, and the main architecture of the messaging hub and the flow of that. And the first, what is the messaging hub? And I'd like to share with you what is the background and the use or the purpose of this. The title of this session talks about the independent and universal all-in-one messaging hub. It talks about the messaging hub, describe the messaging hub, and it is an independent and universal. These are the two keywords for platform, and we want to manage as much components as possible by the messaging hub. As the name says, it is focused on the messaging as the platform. Messaging Hub does mostly two things. One, on the server side, and send a message, intermediate the message from server to client. And another thing it does is that it mediates the message amongst the clients. And the hub sends the client the messaging through five major methods. One, server push, app push, email, SMS, and chatting. And the service working with Messaging Hub do not use all these different functions. It's not the case. And as the conditional domain dictates, they typically use necessary ones, appropriate ones. So when you use a variety of services provided messaging hub, we should really describe how we do it with an example. Many functions are made available in the form of toolbox, and that may be an interesting easy way to understand that. So of all the functions, only the items amongst all those you have, you use the ones you need to constitute your product. And next, let me explain the background of the messaging hub. First, let me talk about the typical polling and the client, to get the updated information on the server, it polls the server and periodically. And however, most of the times, it's just no change that takes place. And if the client count of number of clients increase to hundreds, thousands, and tens of thousands, and if they are checking any update, just in case they are there, and that could really put a lot of technical burden on the network, and waste a lot of network packets, and it's in a way, it's a DDoS attack on yourself. And obviously, you could distribute the database to alleviate that, but still, you don't solve the issue of having unnecessary wasted polling, and you need to change the structure drastically. This problem can be solved by having push mechanism from server, and so that you don't have to have unnecessary traffic. And other associated products, the problems can also be averted as well. For example, Messaging Hub really started as a project to change the polling to push a mechanism. And as I said, there are many other messaging requests to servers. And we actually added a lot of functionalities to enrich the platform. And there are many ways to pay off the technical debt by improve that little by little with the small step maintenances, or create a totally new from scratch, or turn it into a fundamental technology. And there are many systems are tightly coupled, and then you can loosen the system coupling and have a common function on the common domain, so that you can ease the complexity and can introduce independence in the data. And so I chose the third approach, changing to a fundamental technology. And from the source to destination, messaging hub is there and also can operate independently. And it does not have a business domain knowledge. And also to be more generic and usable in different domains, and it can delegate role easily through loose coupling for universal usage. With this background, Messaging Hub was born, and Demae-can, the Japanese #1 food delivery service, is using it. Demae-can has a number of domains. Right now, delivery and merchant domains are using this Messaging Hub. And user, CS, retail, other domains will be covered eventually. And next, Demae-can has a messaging hub, and let me share with you some summary indicators. And peak time concurrent connection can exceed 50,000, and 1.5 million message or up to 2 million messages are processed, and server push maintains the processing time of only 150 millisec. And in terms of a connection time and the messaging, and as we expand the domain, we believe we can handle more of the traffic as well. And the messaging hub is called messaging as a service, and it is more like a platform. And it has to become a platform for different reasons, and the conditions are there. And for a product, there are different domains, and there are a number of projects involved for different domains. And product scale as it grows for the same request. And if you repeat that development many times, and that is because of the different domains, and it can evolve that way, but it hurts the productivity, and it will become difficult to maintain the stability of the service and reliability. And also product service and reliability is at stake as well. And gradually the operation errors can take place, even to the system faulting as well. And in order to cut down the number of repetitive work, you need a new platform to alleviate the situation. But a one-on-one relationship, if you simply expand the functions, you don't need a platform. In this case, you could easily do over-engineering.
But vice versa, for multiple domains, always there needs to be a platform characteristics. So messaging hub is going to be utilized in multiple domains. So N versus 1 is a relationship. So you need a correct and also feature for the platform and reason to be a platform. After joining Demae-can on this product, I have reckoned there are some improvement that needs to be made. We decided to separate some of the requirements for each domain. So one of them is messaging. So it is going to be dedicated to messaging hub. So each of the domain, in terms of the businesses, they will be able to structurally focus on their business, meaning that in terms of the immersiveness and coming up with a better services, it will lead to a motivation, being able to focus. And to be a platform, there are things can do and cannot do, and you need to define this. The reason is for the platform, the standard have to be established, and also a clear intent could be outlined through these processes. So in Messaging Hub, what cannot be done, I think is important. So in terms of universal and independent system, this is something that we must prerequisitely do. So not to be linked to the specific domain, we need to not know about the business logic. So in other words, the domain knowledge of the concatenation should not be defined in this manner. So this is an example. So as you can see, this workflow, the client are connected to the messaging hub, and it shows this process. So messaging hub, the client, what are the domain, what are the services? There's no interest whatsoever. So in other words, the client, whoever client could be, it is agnostic. So the messaging hub, the client that links to the messaging hub, the message is a client not dedicated for messaging hub. So therefore, the client for the original service, the service system that is associated through the service, they need to be issued a authentication token. So authentication token, utilizing this, you can connect it to the messaging hub. The client, we will be able to have the associated server knowing who the client is. And through the server, you will be able to process the legitimacy of the authentication. Same for the server. Don't know who you are. So as I've said, in terms of the messaging hub is not interested in the associated messaging hub. So messaging hub, the association with the external association, there is a library being provided. So the message format is as follow in such cases. So what's important, there are two fields, target. So the client received the message is this target. The subject is from it was going to be defined by the caller. So in terms of the messaging hub that received, the subject has not been defined. And payload is the actual message content that is going to communicate to the client. And this is stratified JSON is going to be utilized. Messaging hub does not care about payload and bypasses it. So in other words, a specific client, what message will be sent is going to be defined as an associated service. So the messaging hub with server and client, regardless of the knowledge of domain, this could be utilized. So messaging hub, in terms of user information and domain information, not knowing them, meaning that they are quite independent. So the messaging hub, in terms of flow, and utilizing this characteristic, it could be associated with any service, meaning that it is independent and universal. So next is messaging hub. The architecture in terms of the overview models and also flow generalization is going to be shared. So messaging hub, the architecture, as we go along through the project, it goes through various changes. So it's a domain that comprises of multiple modules. So it starts with a single module. So the role and objective of them, it has been this it's been broken up and also has been put together in this format. So the messaging hub module, how they have been configured, I would like to share that with you. So the messaging hub, the messaging router, first of all, in terms of the external connection, the messaging is going to be routed and according to the business requirement, is going to be connected effectively. Connection manager going to be connected with the connection. So WebSonic Connect is going to be utilized for server push. So notification app, excluding server push, the third party notification channel is going to receive the message. So FCM and SNM email are going to be sent in this case. So message app, in terms of the client message data is going to be managed, and there are the result of the sending message that also are included. And the message receiver, in order to make sure that this is going to be well connected, the receiving the message, there is going to be a callback, and that is going to be the objective.
And consumer proxy separates the data separately, and there is a benefit of doing that. And there is a business logic change does not can solve the rebalance issue of consumer side, and also eliminate the limitation of the scale out of the client. And chat application app manages the data. Operation app works with the service area and provides the necessary processing of schedules and so on. Monitoring, alert, and integration services are taking advantage of the third-party services. And the services and projects are bound to change. Therefore, you need to forecast and the changes. And to bring efficiency, you use libraries. And there are three libraries. And for the collaboration with the outside server, we have an external library as well. And the messaging hub have gone through many changes, and we have reduced the the very complicated code, we use libraries for services and others, and we have libraries supporting different modules. And this is a basic system. We've seen the basic system configuration. Now we'd like to see how message flows with the external message flow. We have external library to send the message to the router. A router receiving the message and will contact the Kafka and changes that to the cold side. And for large processing, message router process delay may impact the sending side, and this really prevents that. And a connection manager can be sent, or apply push notification app. And this routing really decides which is more appropriate. Client wants to, if you want to connect to connection manager, it will connect that. But if the message router uses a message router in a very short time, client connection may get disconnected or may fail. Then it has a fallback system so that the notification app, the message can be processed, and the app can store such message as well. And from the caller side, and it uses UUI so that it can have the state of a sent. And if when the client receives that, receiver responds back. And WebSocket connected client, and also direct MS SCMs and notification channels can sometimes desired to be used. And external libraries defines the method to do that. And just like earlier case, it goes through the router to communicate. And chat is a recent request. Message Hub is connected with client with WebSocket, and that's a basic specification. For chat request, it can process most appropriately, and it's the benefit. And the chat client supports the communication, so it sits behind the chat connection manager with the chat app. But the food delivery domain has a very unique request. A driver and user need to chat. And let's consider how it works. And our traditional chat we have in mind typically assumes it's you are chatting with somebody you know, like friends. But for food delivery domain, and driver and user need chat even though they don't know each other. And to set up the chat room, who does that? If it's the driver, the user information needs to be known by the driver. And driver also has to do something extra than the food delivery, because setting up the chat is another burden. But the user, if user is to set it up, it's more complicated because he or she doesn't know who the driver is. And also, the chat room has to be removed after the delivery is completed. And given message sometimes needs to be capable of being chosen and sent. Now, how should we support all this? The chat room, and this is life cycle, and options are needed to support the different life cycle requirements. And Message Hub has a natural separation of domains to receive call from outside messenger. Now, some of you may wonder, Message Hub I thought that you may think that I stated it doesn't getting into the other systems in the same federation. But this is a very food domain system, so we may be getting involved in the domain. Well, regardless of the domain knowledge, I generalize the chat function in designing this to support the food domain. And so chat use case was developed, and the edge cases were managed separately. And next, let's talk about the important part of the platform architecture. A message hub architecture, as I designed and developed, it was very important to generalize that. And without compromising the independence, we need to generalize and make it more general purpose. And to protect both the independence and generalization, I really worked hard to generalize the requests and then reflected that in the messaging hub. Messaging hub uses a number of infrastructure technologies. Once the code is pushed, CI2 analyzes whether it's statistical analysis and look at the build, and the image is registered in the build, and then it is delivered to different phases. And container, we use a Kubernetes container, and object can be used as a customized, and the local Exchange Hub can be tested with this infrastructure configuration management. And next, for the messaging hubs to be safe and reliable, what are some of the key focuses we had? And here, what I will be explaining, it's not just about the messaging hub, but for any connection-based messaging system should have the same considerations. And the messaging hub is connected with the client with WebSocket. So connection management is very important. And the diagram you see is for the router is used and operation app are configured, and it shows how they are working together. And instead of the details, I'd like to focus on the larger macro point.
So basically, connection manager, it's going to manage the connection with the users, and it has its responsibility. But the connection information with the users is on message router. It's an information that needs to be acquired because the message is going to be routed to the right destination. Number one, the target users, whether or not they're connected or not. We need to understand the connection. So in the connection manager, number two, where is the client that is also being connected? So the connection information, there is a different storage that are utilized for the synchronization purposes. And also the message router and the connection manager. In between, the server connection is utilizing socket. In between server, the socket connection and also upgrading, the information is going to be managed in the storage. So the server updated information is going to be produced in Kafka and Kafka event. So the message confirmation of the receiving of the message, acknowledgement. So the messaging hub, the message safely reaches the client or not. We do not know. So the server push, the I/O buffer, the message is going to be flashed, and that's the only message that you know. So app push, the third-party FCM, we will need to get a response that you have received the message. So the message, whether or not it received the client or not, we need a flow to make that judgment. So message hub, yes, you can know this is the flow that's been added in the content of the message. The client making sure that they have received the message, or the messaging hub need to know. So therefore the ACK information. So client receiving the message, the ACK information, inclusive of that, the messaging hub needs to notify that. So the data utilizing the confirmation of the message, the message that has dropped in between, there's going to be a callback process that also could be functional. The connect is a connection confirmation with the client. So the client network environment, the actual connection may be truncated, but the messaging hub, because of the not knowing the environment of the client, this may not be understood. So the network environment is not sufficient enough in these cases. So in a simple nutshell, this smartphone is going to be switched over to a specific mode. So this is a situation where it's a half open state. So the messaging hub the client connection has been truncated, not knowing that have happened. So I/O, the message have flashed, and making judgment that it successfully have sent. But the client, because it's a truncated communication, they have not received the information. In order to overcome this issue, the messaging hub on the client, there is a receipt pong confirmation that is needed, and ping pong. So it's sending a ping always, and to the pin, the pong is going to be received. So with a specific time window, if the pong does not be received, then we are going to conclude that in the server. And pong up on client pong, the message hub up through adding pong up, the client have not received the app. So in this case, the reconnection could also be done again. So the message receiving confirmation and the connection confirmation, we would be able to process the information reliably and safely. But still, there may be a way around. So in other words, no connection and our app push is also turned off and it's offline. Then at that timing, how should we deal with the message that is going to be sent? So without being sent to the client, shall we leave it as it is, the missing messages? So W3C, the working group, are also saying that user agent on offline for temporary offline, it still needs to send a push message. So W3C. So if it's online, the message should be stored, and that is a guideline. So in other words, under such circumstances, there should be a way in order to get the message across to the client. So due to these reasons, the messaging hub, the message carried to the client, they are going to store the message for a certain duration of time. And the client is when turned on to online situation, the connection is going to be connected. And also acquiring the newest message, the client will be able to receive the message that they have not been able to receive. So once again, in terms of confirmation of the received message, the messaging hub to the client is going to dynamically will be able to notify that to the client. I would like to wrap up. The messaging hub, the next plan objective is a multiple objective and use point, more service, more domain, and more participant. And in order to achieve this, more simple and more powerful service needs to be achieved. So this session, if you are interested in Message Hub, so there are some technical blogs that I have written. So if you have time, please take a look at this blog. So this will be the end of my presentation. Thank you very much. So from here, we'd like to offer plus talk and some of the areas that you would like to dive into the session. We would like to discuss this. And of course, this also would like to welcome you for posting questions from the viewers. So there's a question mark button on the right bottom of the screen. So please, we'll be waiting for your questions to be posted. So that's an interview. We have Koji Lin from Line Fukuoka. So if you be kind enough to introduce yourself very briefly, please.
Okay, thank you. Once again, my name is Lin. I work for Line Fukuoka. I'm a senior manager of the Development 1 department. Thank you very much. And having listened to the session, is there anything that came to your mind? First of all, it was a very good session, and especially the messaging were separated and platform was made more simple. And first question I have is that what you presented this time, the flow or the sequence of messaging, and also Kafka partitions were also described. So Message Hub itself, does that guarantee the order of the messaging as well? Thank you very much for the question. The messaging sequence order, whether it is guaranteed or not, was the question. Currently, we do not guarantee that in the process of distribution distributed processing, it is difficult to guarantee that, especially for third party. We delegate the message to the third party, so we cannot guarantee for the third party's processing. But client side can check the order of the reception and change the orders. And so we send the index information to the sender as well. I see. That's will be very challenging, but that function will be very great. Okay, let me ask the next question about the architecture.
Well, this time overall, thank you very much for describing about the platform overall. But let's say error handling, bit management. How do you do that? Especially, as I've said, the FCM when you utilize them on application app, and the dependency. There will be a dependency to outside external system, and if there is some failure on the outside system, let's say who's going to be in charge, the client side, can you define that? How do you overcome these issues? Thank you for the question. First of all, error handling. The third party, if you fail when calling, the explanation on the back of policy will do it retry. And if it does fail again, which is likely, in those cases, as of now, the error processing is done as is. But the error, as a data, we store them. So utilizing scheduler, the error, we'll be able to reprocess the error once again. And if you fail, the scheduler in the initial stage, it was within the specification. But the characteristic Demae-can, it's a latency processes could be quite sensitive. So push to pay. Excuse me. So that is therefore excluded. From the messaging perspective, sending the message, we put the maximum effort. So therefore, I think it's a required feature. So for retry, through retry, if you fail to deliver the message, then the scheduler is going to go through the reprocessing, and that's how we work around. But what's different from the past is the federated service. There are some options that you can contact directly in order to support some of the other means of overcoming this issue.
If that's the case, the retry results, including the order, the client side can manage the whole thing, right? No, that's not the case. And what I said is the messaging hub, inside the messaging hub, such retry takes place. That's what I was explaining. In terms of the order guarantee, as I said, that because of the distributed processing, it is difficult to guarantee the order. Third-party order guarantee is not to be really guaranteed by the messaging hub. So that client can manage that. And messaging hub sends the order information. Retry processing is conducted by messaging hub for fail path and schedule fail first. And these are some of the options. The client can select them. All the others are handled by messaging hub, and that's how you should interpret. Understood. I think it is very interesting. Another system design related question. That messaging hub, message router, and the client, and which connection manager is in charge of that connection. That the messaging router and connection manager uses a socket connection and also use storage. And for hook and lookup service, it implements all those functions themselves. Now, a PubSub type service is very similar to this. In that case, in designing that, why didn't you use the PubSub type middleware and you implemented it yourself? What was the reason for that? I understood the question very well. In the initial configuration of messaging hub, messaging router, when it communicate to the connection manager, we had PubSub initially, but now we have a message router. Sends the check with the router connection information and hits the connection manager directly through routing. But if there is only one connection manager, the PubSub manager, one use of the PubSub manager is the easiest way. But there are a number of connection managers in reality. For example, if the connection manager, there are 10 of them, let's imagine, and if you have PubSub to support them, what will happen? And the first subscribed connection manager will consume messages in a kind of a multi-consumption manner. And one message is to be received by a client. For that purpose, the remaining 9 managers have to also manage that. And it's not the message they are handling. So the message they don't need to receive. They need to receive and validate and dispose. And this becomes necessary. So unnecessary traffic will be generated that way. And therefore, the case we did not use that, accept that case. Another case is that the server client connects manager just randomly one will consume. Let's consider that example. In that case, amongst the connection managers, the crash structure needs to be there to connecting them, and the crash. Making sure that it is not their own client, but if others, and we crashed, but you have to communicate the situation to other messaging managers. So the forwarding is necessary. So full mesh structure is necessary. As I said initially, I thought about using full mesh for management. So amongst the connection managers, we have the messaging forwarded all the time. But if the message router can be introduced, and message router can do a lot of work message router managers were doing, and therefore connection manager can actually focus on their message management, and the router can look at the connections, handle the connections. So by having message router, message forwarding, a lot of the work messaging manager were doing are now carried out by the message routers. And a message router, as the name says, it really routes the message. And the message router may lose its role if they are not separated. So for different purposes and roles, they have to be assigned and have a direct connection, and which manager it is associated is very detailed control and understood. I think it ended up to be a very simple structure, so I thought it was good.
So there are several questions I would like to ask, if I may. So the generalization of chat app. So in terms of sample, the driver and client, you showed us example. But in the future, in terms of generalization, the structure of generalization, maybe in between different users, user and merchant and drivers, and that also could be applied in a such a structure, because there was only one slide, and the left-hand side was the chat layer, and the special use case on the right. So the use case is like a plugin as a function. Is that how you offer them? Is that correct? Thank you for the question. There may be some misunderstanding, because in fact the business logic was included in the business logic by feature. It's separated, therefore. And the example that I have alluded to, the user and driver in the delivery, the chatting is just one example. It is not general use chat use cases, how the messaging hub is going to correspond to that. It was just an example for that. And in between users, as you say, and merchant and users, and client and users, to each of these chat and the current specification, it is already being generalized. So the generalized function, in using them, you will be able to choose from the option. In other words, users and CS chat is being added on chat app. All the modules is not going to be increased. So the possibility is that, like deep in chat, there are some sensitive information. So DP, the database, had to be managed separately. I hope this answers your question. Yes, I understood. Thank you very much. So the current chat app module, without any changes, you'll be able to connect different type of users, and the message could be exchanged by different type of users. That's the structure. I see. Thank you. I have understood. Thank you very much.
That is correct. That is correct. And the WebSocket and between server communications have been implemented. And the currently connection manager based server, how many connections can be supported by a server? Average, and also what is the maximum limit you tested? Do you have any numbers? This may be a long answer, but I'll try to be brief. Now, what is the maximum connections? It's difficult to answer exact answer because of the operational conditions and the settings. There are a number of things, local port bindings, how many you need for NETI. There's no limit as long as you have a local port binding. And Unix server setting, Linux server, and port range, and amongst the port range, within the port range, how many can be used, and for sockets, and the file scripter is used for operation. So ulimit is used to check how many open files can be used, and for messaging hub, the proxy. We use Nginx, and we have the maximum proxy for management, set and managed. And that's another information needed. I know I'm not answering your question exactly, but it's just to show that there are so many things we need to check to respond to that with the messaging hub, and we are setting to 5,000 to 10,000, and that's the range we want to maintain. And we could probably add more connections, but we want to maintain that level because we want to manage conservatively. And if the connection number goes too high for a particular server, and that server has a problem, and all the clients connected to that server will be impacted. So we are thinking of the appropriate size, and the high volume service needs to be managed with the stability, and that's a high priority for such management. That's it. Thank you very much. I understood it better now. So provisioning has a lot of things to be considered, and it's very clear.